The ultrasonic sensor works a little bit differently than regular sensors. Regular sensors use analog pins. The ultrasonic sensor actually uses 2 digital pins. If you take a look at the sensor, you'll see that there are 4 pins that you have to plug in. There's 5 volts, the trig and echo pins, and then ground. Trig and echo are the 2 digital pins that will be defined in your code. The way the code works is that one side of the sensor emits an ultrasonic frequency. The sound travels out from the sensor and bounces off of an object. Once it bounces back, the other side of the sensor receives the signal. It calculates how long this bounce takes, and it uses a conversion value to change that into inches. So for example, as this object is getting closer to the sensor, it will read 7 inches, then 4 inches, then 2 inches. Here you can see the values change as the object gets closer and further away from the sensor.
Here are 2 versions for controlling the motor using the ultrasonic sensor. The vibrating motor is on pin 9. Hook up the ultrasonic sensor with the trig pin on 7 and the echo pin on 8. Notice that the trig is an output. It sends out a pulse in ultrasonic frequency. The echo is an input. That's because it listens for when the sound bounces off of objects in front of the sensor. We're also going to convert the value that it receives into inches. Once you have the value in inches printed to the serial monitor, we want to convert that value so that we can change it to a frequency vibration. Use the map function. We're mapping the value for inches. It goes from 120 inches to 0 inches, and we're going to change those values from the values 0 to 255. That's because the digital pin, especially when it's on the pulse width modulator, it can send out a pulse from 0 to 255, changing how fast the motor will vibrate. Now that we have mapped this, we're going to call the new number vibrate. We're going to analog write the motor to this new value of vibrate. So as the object gets further away, the motor will vibrate less, but as the object gets closer to the sensor, it will vibrate more. There's additional code down here for the microseconds to inches. An alternative can be found in this code. The beginning is the same, except that the trig and echo pins have been changed. Here, instead of having the distance become a specific frequency, we have created if statements. If the inches away from the sensor was between 48 to 60, the motor would vibrate at this frequency right here. High for 50 milliseconds, and then low for 2000 milliseconds. If the value was between 36 and 48, the frequency is now slower. If the value is between 24 and 36, again, the frequency changes, and so forth. If none of the conditions are met, the motor simply is turned off.